Here's another video from my dirty modeling desk. I received a couple of requests and comments about trying to show how I do some of the Steam DCC systems I do in N-Scale. And so I'll do a quick crash course video about the things that you'll need and probably want to consider. But this is how I do N-Scale Steam. Basically, I only go to two different types of products and decoders. The Tsunami 2 Steam is one of the great decoders. It is, as you can see, a little bit larger, but when it comes to Steam, sound, automatic functions, it's really great, and including the DDE, Digital Dynamic Exhaust Effects, really can't be beat when you have a Steam, and the chuff just works with all that. But when space is limited, you got to look at some other solutions. And here you'll see the two Locksound 5s. The one on the bottom is a Locksound 5 Nano, has four outputs in terms of lighting, and also has a provision to solder on a pad for the a keep alive, and I'll show you that later. The hard part is that you got to cut some of this clear coating off to get to the ground solder pad down in there. If you have a little more space, you can opt for the regular Locksound 5, and the ground solder pad is right there underneath the clip-on Next 18 solder patch. The nice thing about all these decoders is that if the decoder blows, you can pretty much unplug them, keep the harness in the steam locomotive, send the decoder in to get work done, bring it back in, and plug it right back in, and you're up and running. So these are the decoders, and just to give you a reference size, this is a Southern Pacific 3D print of a 120C tender. Inside, kind of hard to make out, it's all white, but that kind of gives you an idea how much size you're dealing with. Here on a brass model, here's me trying to stuff a Tsunami 2 into a similar 120C tender, so it gets really tight real fast. And this doesn't even have a speaker in it. It's got the keep alive in the back and the decoder in front, and I'm still trying to make space. So smaller tenders like the 120s and 160s, you're probably going to want something like a Locksound Nano, which is really good. I mentioned a keep alive. Steam, as you know, if you're dealing with brass steam or even just regular steam, pickup is a lot less consistent, and so I always put a keep alive inside. So that's a TCS KA1, great little unit. It will solder onto the ground side of the Tsunami or the Locksound decoders, and the blue wire goes to the blue side. So imagine these two units needing to be inside of your locomotive at least, and then you're probably gonna have to throw in a speaker. Okay, that's a Soundtrack's Minicube 1. That's an 8 ohm speaker. Probably one of the preferred speakers that I will use on, say, like a GS4 tender or something a little bit larger. There are bigger solutions. If you're running a big boy or something, you can use something even bigger. Typically, I will build something on my own using just a one of these speakers ordered from from DigiKey. You buy them in big blots for $2-3 or whatever, and you build styrene enclosures to your size and fit. If you're too lazy to do that and don't want to deal with that, there is another smaller solution here, which is the Minicube 3. And you can stack all those enclosures up to you pick among the 3 different enclosures here for the different depths. So a couple of options for there. This one obviously is not, it's not as great in the low frequency response, just because it's, the enclosures are smaller and the drivers are smaller. But I do like this better because it is still an 8 ohm system, and it really responds to these decoders a little better. Nothing to bash against the other Minicube. There's a Minicube 2, but that's I think 16 ohm speaker or something weird. It just doesn't seem to have quite the same frequency response. So when I need something in between this and a Minicube 3, I'll build it my own. So that said, let's see what this kind of looks like. Here I got one of these projects going on right now. This is that same 3D print. And you can maybe see right here. This is the base of the tender. It's got trucks. These are Kato UP water tender trucks that you order the parts and you can hard solder wires onto it. They're great for rolling resistance and fantastic pickup. And this tender floor was designed just to clip these in, so it's fantastic. Hardwired up to Keep Alive, okay? And then there's a lock sound nano decoder. You'll also see that I solder in a little peg and a DIP pin socket. I connect this to that to power the Keep Alive. The reason I do that for the lock sounds is that the lock sound or lock programmer does not like to program locomotives that are that have the Keep Alive on it. It can't talk through it. You can buy these from, well, in the good old days there used to be Fry's, but you can buy these things in huge amounts, and they work as great as connectors for circuits inside of an N-scale steam locomotive. Okay, so decoder, Keep Alive, and inside you can see my little styrene speaker. Okay, it's already soldered on, enclosure is built, soldered in, and so when I do these things for the tighter constraint places, I will use one of these or use this on my own. For customer stuff, I typically use the soundtrack stuff just so that nobody can say, hey, it's gone bad. These speakers, well, they are cheap cell phone speakers, and so they are mass produced and not sometimes not as robust. You also see these quarter watt, probably 850 ohm resistors. I'll just buy them and put it in here, solder it in line from the decoder output. Okay, you'll see my motor wires running to the front, as well as some of these really fine LED wires. LEDs don't draw a lot of current, and so you can use super fine wires to do that, to power them up. Here you also see LED onto the back side of the tender, and that will power the rear backup light. So that takes care of it for the tender side, and all this should package in. The Keep Alive will deal with a lot of the tender weight issues and keep contact on. On the locomotive side here, this is a Kato C57 base. It was designed to go onto this track 29 Sunbeam, or a Pacific P14 Pacific locomotive shell. This is a project I'm doing for Robert at track 29. This is his. Painted it up and did the stuff. On the locomotive side, basically all you need to do is have provisions for a headlight. Okay, and you can maybe see that kind of soldered in there. Okay, I'll put a firebox light in these things whenever there's space available. And then you have the two motor leads coming out of the back of the motor. Just mark them for positive, negative, so you can keep the rotations in check. Nice thing about Katos is that Katos have great pickup on the front, and they transfer that pickup through to the tender. And so I'll probably wire some pickup wires through here and add it on to the tender pickup. So I got tender and locomotive picking up all together. So basically, once you kind of got a confidence in packaging and you're able to route all your wires, start putting it together, and that's what one of these projects looks like. That's an easy project, or easier project. There are cases where you have to get definitely smaller. So here is another project going on for a friend. This is a C9 consolidation. It's brass, so you can see the motor wires coming out of it. You'll see firebox wires, the firebox and the headlight negative wire, as well as they share a common positive wire. Things get really hairy when you start looking at, this is a C100 tender. And just for reference, it gets really tight, even with just a lock sound 5 regular in here. So in this case, if I'm trying to fit in both a Keep Alive and a decoder, and the speaker will go here inside of the oil bunker, you just kind of gotta shove them in order and try to make space, and you probably use the nano for sure. This one will also keep the same, you know, tail light. It's drilled through the brass. That's why brass is such a pain. And then, you know, I will route all my wires through the front of the tender and out of the bottom of the cab. Kind of hard to see here, but I'll run them out of the bottom of the cab. The end result is kind of like a tight, potentially clean junction, and I will leave all my locomotives pinched together. So this is an Allegheny that I'm doing for myself. I'll just put the drawbar on. I'll put a pinch, like aluminum tube, and pinch it so that it doesn't come off. And you can see all the electrical wire that transfers between the tender and the back of the locomotive. So Allegheny done. So I think that covers most of how I do DCC sound in these things. Yeah, knowing what parts are being used is really the easy part. It's the skill of, you know, how to run the wires, what's too much wire, what's not enough wire. You know, and I will bring this out, you know, on a really tough day. I have put DCC sound into one of these guys. This is a Kato, you know, C57 tiny tender. It's got weight and everything inside of it. You can preserve the weight, you know, and all I can do is put a very, very small speaker, put a nano inside of it, and also put a couple of small SMD resistors to have a little bit of keep alive in it. So that's it. Look forward to my next test video when I finally put this Sunbeam up on the runners and get that project out of my hair. I think that's about it. Oh, and if you're asking about LEDs, I would just say I always use surface mount LEDs that are pre-wired. 0402, that's the dimension type. You buy warm white and you put it on, and you wire it in with the resistor, and that's kind of it. So lots of DCC projects going on. That's my GS1 and more brass. That's the F2, and yeah, brass everywhere. Things to fix and do. So yeah, that's about it this time. Enjoy.